Imagine stepping onto Mars. No spacesuit. Just you and the red planet. You'd have exactly 60 seconds before you're dead. In the first 5 seconds, the pressure is so low that your blood and saliva literally begin to boil inside your body. You aren't burning, you're vaporizing from the inside out. While your lungs are gasping for air that isn't there, the minus 60-degree cold is flash freezing your skin, and raw solar radiation is cooking you like a microwave. You'll lose consciousness before you can even scream. We call this planet our backup plan. But now you're going to find out why Mars is actually a high-tech death trap. We talk about Mars like it's our future home, the next step, the backup plan. The planet that saves humanity when Earth eventually fails. Tech billionaires invest billions into massive rockets. Space agencies release polished timelines and cinematic animations. Hollywood shows settlers walking beneath glass domes, growing crops under orange skies. It all feels inevitable. But almost nobody says the uncomfortable part out loud. Mars is not just difficult. It is the most hostile world we have ever seriously considered sending living, breathing humans to. When you look closely at the science, not the artwork, not the hype, the dream starts to crack under the weight of physics. So in this video, we're not treating Mars like a romantic frontier. We're treating it like a real place, a real planet with real laws and real consequences. And we're asking the question that should be at the center of every mission plan. Should we actually send people there? Distance is the first reality check. Mars sounds close. It's our neighbor, right? Not even close. On average, Mars sits about 225 million kilometers away. At its absolute closest, that distance shrinks to around 55 million kilometers. That is still so far that if you drove a car at highway speed non-stop, it would take over 60 years to get there. With current rockets, the trip takes 6 to 9 months one way. 6 to 9 months in deep space. And that's just the beginning, because the real danger doesn't start during launch. It starts the moment you arrive. Mars technically has an atmosphere, but calling it an atmosphere is generous. Surface pressure averages about 6 millibars. That's less than 1% of Earth's sea level pressure. This isn't thin air, it's almost a vacuum. If you stepped outside without a suit, your lungs couldn't pull usable oxygen. The air is 95% carbon dioxide. Oxygen makes up only 0.13%. On Earth, we breathe 21% oxygen. On Mars, you are not breathing. You are suffocating. At the same time, the low pressure would cause your body fluids to begin boiling at normal body temperature. Not because it's hot, but because the pressure is too low to keep them liquid. Saliva, moisture in your lungs, the fluids lining your eyes, all destabilizing at once. It's not dramatic exaggeration, it's basic physics. Now, add radiation. Mars has no global magnetic field. Billions of years ago, its core cooled and the protective shield disappeared. Without that protection, the solar wind stripped away most of the atmosphere. What remains blocks almost nothing. Radiation levels on the surface are about 40 to 50 times higher than natural background levels on Earth. A round-trip Mars mission could last 2 to 3 years. That amount of exposure pushes astronauts to, or beyond, current career radiation limits. We're talking about increased cancer risk, possible cognitive decline, nervous system damage, and accelerated aging of the heart and blood vessels. And blocking this radiation is extremely hard. Some cosmic rays pass straight through metal. When they hit spacecraft walls, they can create secondary radiation that makes things worse. This isn't just an engineering problem, it's a biological one. Let's say you bury your habitat under Martian soil to block radiation. Problem solved? Not exactly. Martian soil contains perchlorate salts at levels considered hazardous on Earth. These chemicals interfere with thyroid function, which affects metabolism, development, and brain health. And the dust itself is a major problem. Martian dust particles are incredibly fine, smaller than red blood cells. They carry static charge and cling to everything. They stick to suits. They stick to equipment. They even stick to lungs. In 2018, a planet-wide dust storm lasted nearly 2 months and permanently ended the Opportunity rover mission by blocking its solar panels. When dust storms hit, solar power can drop by more than 90%. Temperatures fall, life support systems strain, margins disappear, and you are tens of millions of kilometers from the nearest replacement part. There is no quick rescue. On the International Space Station, rescue can arrive within hours. On Mars, a radio signal takes between 4 and 24 minutes to travel one way. Real-time help is impossible. If something critical fails, the next launch window home may be more than 2 years away. Now think about what the journey does to the human body. 6 to 9 months in microgravity causes bone loss of 1 to 3% per month. Muscles shrink, the heart weakens. Vision can change permanently due to pressure shifts in the skull. By the time astronauts reach Mars, they are already physically compromised. Mars' gravity is only 38% of Earth's. That may not be enough to fully stop the damage. After spending years in reduced gravity and then returning to Earth, astronauts could face severe skeletal fragility, muscle weakness, and long-term cardiovascular changes. Some scientists warn that full recovery may not be guaranteed. Then there is the mind. Years in confined spaces, delayed communication, no fresh air, no open sky, no walking away. Isolation studies show sleep problems, reduced motivation, rising tension, and cognitive fatigue. Even when participants know they can leave if necessary, on Mars there is no exit, no evacuation, just metal walls and the same small group of people for years. Supporters argue that humanity needs a backup planet. If something catastrophic happens to Earth, we need insurance. That sounds logical. But is Mars truly insurance? You cannot breathe the air. You cannot walk outside without a suit. You cannot shield yourself easily from radiation. You cannot rely on your body staying healthy long term. That's not a second Earth. That's a fragile outpost with enormous risk. Terraforming is often suggested as the long-term solution. Warm the planet, release carbon dioxide, thicken the atmosphere. But current research suggests even releasing all known CO2 would still leave the atmosphere too thin for stable liquid water, and without a magnetic field, any thicker atmosphere would slowly erode again. Full terraforming would require technologies we do not yet have and timescales that stretch centuries or longer. Humans evolved for Earth, for full gravity, for breathable air, for a thick atmosphere and strong magnetic shield. Mars is not a slightly harsher version of home. It is fundamentally different. That does not mean it is not worth exploring. Robotic missions have transformed our understanding of the planet's past. We should absolutely continue sending rovers and orbiters. Machines do not need oxygen. They do not lose bone density. They do not suffer isolation. They do not get cancer. There is something deeply human about wanting to go. The same curiosity that pushed us across oceans now points toward that red dot in the night sky. That drive is powerful, but wisdom matters too. Mars is a magnificent, deadly laboratory, and maybe the bravest choice is to study it from a distance while protecting the only world that already supports us perfectly. Earth, the only place where you can step outside without a suit. Take a breath, feel the wind. Look up at Mars shining in the night sky, distant, beautiful, and safe. I really hope you enjoyed this video. If you're curious about the limits of human space travel, consider subscribing. I'll see you in the next one.